Okay, this is the application part of the question. Remember in the first video, we were asked recall questions, definitions, and formulas. Now, in question 2.3, calculate the magnitude of tension 1 in string P. Okay, now gonna have to really focus. Okay, first what we're gonna do, we are going to write down some information here. So I want us to look at that. We have a 20 kg mass and a 5 kg mass respectively, and a 200 Newton force is pulling in the opposite direction while the two masses are hanging. Okay, so because the two masses are hanging, we can say that we have weight total, which is going to be obviously mass 1 plus mass 2, all multiplied by the gravitational force, which will be 20 plus 5 multiplied by 9,8, which will then equal, I'm going to put that in the calculator. So we're going to say 20 plus 5 times 9,8. That's going to be equals to 245 newtons. Okay. Now, what we're going to need to calculate the second tension on its own, right? We need to say, okay, wait, let's go back to that diagram there. Now, there's a 250 Newton force pulling, right? So that tension, that T2, is experiencing that 250 Newton force, right? That's the upward force. And then the 5 kg is pulling it down together with the 20 kg. Okay? So this means that we are going to say that, I'm going to come here and say that F net is equals to mass times acceleration. F net will be T2 minus weight total, right? Which will equal to mass times acceleration. Now, because we used T2 and the total weight, we must also add the total weight when it comes to the mass. So we're going to say 250 minus 245 is equals to 25a. And if you calculate that, your acceleration should be 0.2 meters per second squared. Okay, now we have acceleration. Okay, to then calculate T1, remember this acceleration is for the whole system. So that means it would apply to the second tension as well. So I'm going to do this. Then I'm going to say F net is equals to mass times acceleration. Now, I'm going to say T1 minus weight is equals to mass times acceleration. Now, T1 is what I want, so I'm going to leave T1 like that. Then I'm going to say mass times acceleration plus weight will give us T1. Now, the mass that I'm going to use here with respect to T1, I'm only going to use the 20 kg, not the whole system. Okay? I'm only going to use the 20 kg. So when I come here and say 20 multiplied by 0.2, then the weight that I'm going to use is 20 as well. So plus 20 times 9.8, which is equals to 20 multiplied by 0.2 is 4 plus 20 times 9.8 will give us 200. 200 newtons. So that is the force on T1. Happy? Last question. Now, when the 200 Newton force is replaced by a sharp pull on the string, one of the two strings break. Which of the two strings, P or Q, will break? Now your answer is Q. Why? If you add a sharp pull, right, that causes string Q to experience a massive force, a spike in the force of inertia, because right now it was standing still, right? This now would force T1 to pull with a great